Hello? Oh, finally. Good. Okay. All right. This wasn't working earlier. All right. Today I want to show you how to do gas laws. And the first gas law that I'm going to cover is Boyle's law. So one of the things you need to know is what standard temperature and pressure is. So standard temperature and pressure is a reference point that we can use in gas calculations. So STP is the symbol for standard temperature and pressure, where the standard pressure is 1 atmosphere and the standard temperature is 273 degrees Kelvin. Oh, actually you don't say degrees, sorry, 273 Kelvin. All right, the first law I'm going to talk about is Boyle's law. Boyle's law has the volume varies inversely with pressure. That means as volume increases, pressure decreases and vice versa. Okay? And in this case, the temperature in moles are constant in this gas law. And this gas law is represented with this equation where the initial pressure and volume changes, something changes, and then we're finding another pressure volume. Any of these can be solved using algebra. So depending on what you're solving for, you might solve for that one and you're given those, and vice versa. And this is a multiplication, so you would then do division to solve. All right, so the first example we have at 25 degrees Celsius, a sample of gas of helium has a volume of 400 milliliters under a pressure of 760 torr. What volume would it occupy under a pressure of 2 atmospheres at the same temperature? So we know our pressure volume equation. Okay? So I need to find what I know. A sample at 760 torr has a volume of 400 milliliters. And we say what volume would it occupy at 2 atmospheres? So we're solving for the new volume. Well, the problem with this is that you can't use different atmosphere or pressure units. You're going to have to convert one or the other. So I'm just going to go ahead and convert my, and it doesn't matter which one you convert, the math works out the same. I'm just going to use the 760 torr for every 1 atmosphere, and I'm going to get the 1,520 torr. Okay? Now we can solve the problem. So I have the 760 torr times the 400 milliliters is equal to V2 times the 1,520 torr. And since these are multiplications and we need to solve for V2, you're going to have to divide by torr. And we find that the new volume ends up being 200 milliliters. So we're going to multiply and then divide. So torr cancels. Okay. All right, I have 3 examples. Let's go to the second example. Air trapped in a cylinder fitted with a piston occupies 145.7 milliliters at 108 atmospheres pressure. What is the new volume of air when the pressure is decreased to 1.43 atmospheres by applying force to the piston? Temperature is constant. So we know our initial pressure to be 108 atmospheres, and we know our initial volume is 145.7 milliliters. And we're decreasing the pressure to 1.43 atmospheres, and we're trying to figure out what is that new volume going to be. Okay, so we're going to say 108 atmospheres times the 145.7 milliliters is equal to this new volume times the 1.43 atmospheres. So divide by the 1.43, and we find that the new volume is 1,110 milliliters. So we have a decrease in the volume. Right? Let's look at number 3. If it takes 0.05 liters of oxygen kept in a cylinder under pressure to fill an evacuated 4-liter reaction vessel in which the pressure is 0.98, what was the initial pressure of the gas in the cylinder? Temperature is constant. So we're trying to find the initial pressure, and we were given the 0.05 liters. And we have a final pressure of 0.98 atmospheres. And we have the final volume. It takes oxygen kept in 4 liters. Oops. All right. So we have P1 or X times the 0.05 liters is equal to the 0.98 atmospheres times the 4 liters. So we're going to divide by 0.05 liters, multiply and then divide, and we have a new pressure of 78.4 atmospheres. And that's how you do Boyle's law. Okay? And then I'll do Charles' law the next day.